Hi, my name is Jewel. I am a student from the Matriculation College of Negeri Sembilan and come from the practicum S2 CP4. Today, I would like to talk to you about the third chapter of chemistry, which is the periodic table. Specifically, how to explain the variation in atomic radii down a group. Periodicity. Periodic trends in the size of atoms or atomic radii. Factors that contribute to the changes of atomic radii can be the effective nuclear charge, or better known as ZEF, or even the shielding effect. So what is ZEF, or the effective nuclear charge? Well, it is the positive charge experienced by the valence electrons. Those electrons closer to the nucleus experience a greater force than those that are further away. Electrons moving across the nucleus do not experience the same nuclear attraction. Here, we have an example. How do we find the effective nuclear charge of sulfur at the N equals to 3 shell? Firstly, to find the effective nuclear charge, the number of protons deducts the number of electrons found in the inner shell. In this case, the inner shell is the N equals to 2 shell and the N equals to 1. Therefore, the number of protons, which is 16, minuses the number of electrons found in inner shell, which is 10. Hence, the effective nuclear charge for sulfur is 6. The next factor is shielding effect. It is the repulsion between electrons from the inner shell and the outer shell. An example is the question, why is cesium bigger than elemental sodium? The electronic configuration for sodium is 1s2, 2s2, 2p6, 3s1. The shielding effect is lower for this element. However, the electronic configuration for cesium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, and 6s1. It has a higher number of inner shells, therefore has a higher shielding effect. This causes its atomic size to be bigger than sodium. But wait! What does the ZEF and shielding effect have anything to do with the variation in atomic sizes down a group? Don't worry, we'll get to that part very soon. But before that, have a look at this brief explanation regarding the different changes that occur going down a group. Well, to cut it short, the number of inner shells increases down the group, and this causes the shielding effect to increase. The valence electrons are more loosely held, thus the size of atoms increase down a group. To be more precise, the number of protons increases as the number of shells increase. This causes the valence electrons to be further away from the nucleus, thus shielding the valence electrons effectively from the nuclear charge. The higher the number of inner shells, the higher the shielding effect. The attraction between the nucleus and the valence electrons become weaker. Hence, the sizes of atom increases or become larger down a group. So, in conclusion, the proton number increases. Hence, the number of shells filled with electrons increases, causing the shielding effect to increase. This means the valence electrons have a weaker attraction to the nucleus and are farther away from the nucleus. As a result, the atomic radii of the elements increases down a group. So that's it! Thank you so much for watching my short video. Here are some of the references I've used and quoted in all of my slides throughout this video. Before I end, I would like to share this small quote which I find very interesting concerning chemistry. That's all for now. Thank you so much for watching my video again. I hope that it has been truly informative. Bye!